Hello, I'm Amara Rasgus with Consulting Specifying Engineer and CFE Media and Technology. Today I'm here with Matthew McLaurin from Greenheck, and we'll be discussing a variety of different things about air distribution products. Matthew McLaurin is Segment Manager, Air Distribution for Healthcare, Laboratories, and Cleanrooms, where he leads product management and engineering efforts in the air distribution business unit at Greenheck. Matthew holds a Bachelor of Science degree in Mechanical Engineering from Texas Tech University and has served on several ASHRAE and AHRI technical committees. It's great to have you here today, Matthew.
Yeah, it's a pleasure being here.
Awesome. Well, let's jump right into it. So kind of a basic overview question. When you're discussing air distribution products, what types of products are we talking about?
So mainly it's grills, registers, diffusers, terminal units, air terminal units. So anything that's past the bringing the air into the building, conditioning it, getting it to where it needs to go, and getting it at the right spot. That's really what air distribution is all about, is taking all of the money in the system that you've built really nicely and then making it work properly for comfort in the space. And specifically, if we look at my product offering in healthcare, laboratories, clean rooms, what we're really talking about is these specialized environments where the way that you bring air into the room and remove air from the room is very, very critical beyond just occupancy comfort. It's occupancy safety, it's patient safety and health. It's all of these things that are a whole different layer that a lot of engineers kind of dismiss sometimes as, oh, it's just a hole cover or it's just a grill or return. It's there. So it's a little, it seems very uninteresting on a surface level, but once you really start digging into the fluid dynamics of how the different air streams can affect others in the room, that's where we really start diving into how we can protect the environment, how we can protect patients, make it safe for lab technicians, clean room operators, that sort of thing.
Okay. So let's talk about those specific buildings and rooms, healthcare facilities, laboratories, clean rooms. What are some typical air distribution challenges for engineers? I mean, what do they see and how do they overcome them?
In a lot of these spaces, there are very high prescriptive air change requirements. So part of that is dilution of the air in the space. So you're bringing in a lot of air, exhausting a lot of air. That way you can keep it as clean as possible. But with that, you're bringing so much air into these spaces that you have to be very aware of the airflow patterns and where they're being directed. So an operating room, over the patient table, we use what's called a non-aspirating diffuser. So it's a laminar flow type product where the air moves very, very slowly out into the space. That way you're not mixing the room air into that clean field of air that's coming down over the operating table and over the surgical staff. So you're still bringing a large volume of air. So in those spaces, not only are you trying to deal with the air distribution, but also the coordination with all of the other equipment. You want to make sure that you have full coverage over the patient so that as that air is coming down, none of the particles or bacteria or whatever that's in the air gets into the patient wound site. So that's really, really critical. And to do that, you have to coordinate with everything else, lighting that goes into the space, structural equipment. And so that's the biggest challenge, I would say, in a typical operating room. Laboratories are a little bit different, where you still are bringing a whole volume of air into the space, but you don't want to disrupt the way that the fume hoods are operating or any of the equipment in the space. So we have radial flow diffusers, so they have very short throw patterns, so you can bring in 500 to 1,000 CFM through a single 2x4 diffuser and have throws that just come down into the space in a round shape, but don't really extend down into the room itself. So you're creating that air into the space to treat the ventilation load because all the fume hoods are going to be exhausting that, but you're also trying to prevent air motion in front of the fume hoods with the way that the diffusers are set up. Because if you have air motion coming down across the front of a fume hood, that's going to pull anything out of the hood, and you don't want that to happen. That's trying to keep everything in and captured. So in those spaces, it's really a unique situation where care and placement of the diffusers oriented how they are against the fume hood becomes really, really critical. And so getting a bunch of those diffusers all in the same room where you have a whole bunch of hoods can be a bit of a challenge. And so that's one of the things that why we developed our radial flow products, is to get that large volume of air into the space without disrupting the equipment below it. And then in clean rooms, probably the most prevalent thing is compounding pharmacies that we deal with. So USP 797, USP 800 spaces. So for sterile compounding and hazardous compounding, you want to have as much clean air as possible in those spaces, really because you have you want to have as much clean air in those spaces because you have a technician in there, a pharmacist that's preparing some sort of compound to be delivered to a patient, either an IV or an injection. And so one, you're trying to keep them safe from those materials, but then you're also trying to keep those materials safe from any airborne contaminants in the space. So these have HEPA filtered diffusers, fan powered, so that you're able to drive those air changes both on the supply and the exhaust side. And so it's really important, one, placement, but then also getting the diffuser selection correct so that you're not disrupting what the pharmacist is doing in that space. And so that's one of the big things that can cause some challenges or concerns that engineers need to be aware about.
Got it. Okay, so to follow up with that, in these critical environments, what specific features should an engineer be aware of when specifying distribution products for these kinds of projects?
So in almost all of these cases, you want to be able to specify a product that has met the test requirements from IEST. So they do all the really high clean end standards and codes and guidelines around that. So they have a method of test for filtration efficiency and filtration leakage. So we perform all of those tests on our products before they ship. So that's really important that you have that type of product in these applications, because those are going to make sure that they're performing with the uniform velocity, minimum aspiration on the non-aspirating diffusers, that the throw is going to be correct on the unidirectional diffusers and radial throw diffusers. And then for the fan filter units, it's really important to specify a gel seal filter that's room side replaceable. That way you have access in the room, you can replace it without having to decontaminate the whole space again. So you have that room side access with clean air coming through. So that's one of the biggest things. And really, across all of the HLC products, so the healthcare, laboratory, and clean rooms, welded back pans are really a critical thing. That way that you're not getting any infiltration from the ceiling plenum as air is being supplied into the room. So you want to make sure that you keep that as clean and tight as possible in all these situations, because we're really super concerned about contaminant and contaminant motion in those spaces.
Okay, well, thank you, Matthew. That is a ton of information. I do appreciate your expertise here.
Absolutely.
Yeah, so today I've been speaking with Matthew McLaurin from Greenheck. Once again, we do appreciate your time, and thank you so much for joining us.